This very quick tutorial is meant to draw the distinction between two commonly used words. They are mass and weight. They're not quite the same thing. And think of it this way. You say you have a 10 kilogram mass in your hand. You take it to the moon. You still have 10 kilograms of that mass. Say it's a piece of iron. It's 10 kilograms of iron. That's a specific quantity of iron. And you take it to the moon, you still have 10 kilograms of iron. If you have 10 pounds of iron and you take it to the moon, you know it no longer weighs 10 pounds. It weighs 1/6 of that. So there's a difference between these two words, mass and weight. Mass is given by the letter M, and weight will indicate with the letter W. Usually, sometimes not. Another symbol that's commonly used for weight is F sub G for force of gravity. And that's what weight is. Weight is the force of gravity on a mass M. So if something goes into a different gravitational field, its mass doesn't change, but its weight does. So an astronaut who appears weightless still has mass. Even in deep space where you truly are weightless, you still have your same body mass. You can convert from one to the other. Weight, or rather the force of gravity, is the product of mass and little g, where little g is 10 meters per second squared. And so very simply, if your body mass, say, is 60 kilograms, then your weight is 600. But 600 what? The unit for weight is newtons. So if you have a mass of 60 kilograms, you have a weight of 10 times that, and it's in units of newtons. So newtons is a unit of weight, but more specifically, it's a unit of force. So weight is a force, because weight is literally your force of gravity. If you weigh 120 pounds and I ask you what is the force of gravity on your body, the answer is 120 pounds. If I ask you what's the mass of your body, that's a different story. Pounds, of course, is imperial units. There is a way to convert from imperial units to SI units. 1 pound is 1 divided by 2.2 kilograms, or rather 1 kilogram is 2.2 pounds. But that's only true on Earth. On Earth only. That is with the Earth's gravity. If you take your bathroom scale to the moon, it's not going to read what it reads when it's in your bathroom on Earth. It's going to read something else, although your mass doesn't change. So I might ask you to convert the mass of something, you, your dog, into newtons. Let's do that as an example. Suppose your dog weighs 20 pounds. That's your dog's weight. I want to know your dog's weight in newtons because it's good to develop a sense of what's a big number in newtons. You have a good idea of what a big number is in pounds, so we'll convert. This is how we do it. We'll go 20 pounds times 1 kilogram per 2.2 pounds gets you into kilograms. And then you take this mass, so this is your dog's mass in kilograms, and you multiply it by 10 meters per second squared. And you get the answer, 90.9 newtons. All right, 91 newtons. And just the letter N. So you found your dog's weight in newtons. So 20 pounds is about 90 newtons. Another thing to keep in mind, you don't quite get 5 newtons into a pound. That's a quick and simple tutorial on mass versus weight. They are not the same thing.